All right, 2 lessons left to go in the entire calculus curriculum. All right, so we're going to talk about volume now, and we're going to talk about, there's 2 methods with volume, disk and washer. So we're going to talk about disk this week, and then we'll focus on washer next week. So finding the area is only one of the many applications of the definite integral. So we're also going to find the dimensions of a 3-dimensional solid. So what we have to do is we have to actually rotate it. So if a region in the plane is revolved around a line, the resulting line is called the solid of revolution, and the line is called the axis of revolution. So again, what we are going to be doing is we're going to be taking the same type of shaded region that we got for area, but now what we're going to be doing is we're going to be rotating it around a particular line. And during that rotation, that will then allow us to determine what type of formula, because what you're going to be seeing is you're going to be seeing both not only horizontal rotations, but vertical rotations. So if something is rotated horizontally, you want to think the x-axis, okay? So if we're dealing with something that's horizontal like the x-axis, that means our parameters are in terms of x, our functions are in terms of x, so maybe we'll make a note, parameters in terms of x, and equations have x's. Equations have x's. Now for a vertical, that's like the y-axis. So then that shifts. So parameters are y values. And the equations have y's in them this time. So you're going to probably have to solve for the y value. You're going to have to sort of switch it. So it says find the volume of the solid formed by revolving the region bounded by the graph. Okay? And we'll go over that uppercase R of x, uppercase R of y thing. So we have the square root of the sine of x. We're going from 0 to pi. So if we think of the sine curve, the sine curve typically starts at 0. We have an amplitude of 1 and -1. The sine of pi over 2 is positive 1. The sine of pi is 0. 3 pi over 2, if I go down the unit circle here, 3 pi over 2 would be -1. And then I need a pi in there. And then bringing us back to 2 pi would put us back at 0. So if we sketched the sine curve, at least part of it, we'd have that. But we're only focusing on this as our parameter, and it's the positive square root. So we are only focusing on this region right here. Okay, so that is what we are calculating the volume of. Again, not area, but we are calculating the volume. So what we have to figure out is it's telling us that we are going to rotate it, revolving the region about the x-axis. So if it's x-axis, that is horizontal, which means we are looking at the first equation up here on the left. So v equals pi. We're going from a to b. And we have uppercase R of x, which is being squared with a dx. So we need to know what a and b are. If we look at our function, though, we see that the parameters given to us go from 0 to pi. What we do need to find, though, is the uppercase R of x. So how you determine the uppercase R of x, because remember, we are going to now rotate this around the x-axis. So this blue shaded region now gets rotated, which means you're going to have sort of a symmetry going on underneath it right here. And you're making some form of a 3D shape. In this case, it's sort of a lopsided sphere a little bit. So now what we have to calculate is the uppercase R of x. Well, the uppercase R of x is the distance from the function to the actual axis of rotation. So what I always like to do is draw yourself a little rectangle in here. Okay? The top of the rectangle is at the square root of sine of x. Y equals, or f of x equals. The bottom of the rectangle is at the x-axis, which is y equals 0. The distance between them is subtracting. So uppercase R of x is the top function, square root of sine of x, minus the bottom function, which is 0. Which in this case, you're just going to end up with the original function that you started with. Realize, though, that that is not always the case. So that value then gets subbed in for our uppercase R of x. And now we continue with the simplifying. So step 1, you want to square. When you square a square root, it disappears. Then we have to integrate the sine of x. Well, when we integrate the sine of x, we get a negative cosine. So we have negative cosine x, and we're evaluating that from 0 to pi. So what I would do is kick this negative out on the outside, keep a negative pi out front, and then we're going to evaluate the cosine of pi minus the cosine of 0. Well, cosine of pi, the x value is -1. Cosine of 0 is 1. -1 minus 1 is -2, and -2 times negative pi gets you a positive 2 pi. And it's volume now, so you have units cubed. So again, just like area, you should not get a negative volume. And what you are going to find with volume now is every single answer not only has units cubed, but it is also going to have a pi in it. And the biggest thing is figuring out your R of x.